my name is Iqbal Khan. As he said, I'm the President Technology Evangelist of AlachiSoft. By the way, we're changing our company name because everybody has a difficulty pronouncing it. We're going to call it NCache Labs. So it'll be a lot easier. Pretty soon we'll change the name. So today's talk, I would very much prefer to make it more interactive so that as I'm talking, if you guys have questions, please stop me so that we can go over that topic at that time instead of waiting until the end. My talk is a combination of architectural concepts and some code examples as part of it. Okay. Let's get a few definitions out of the way. Scalability, and again, this is for completeness purposes. Most people know this already, but scalability is not application performance. It is application performance under peak loads. So if you have an application that runs super fast with 5 users, it's not necessarily scalable unless it can run the same way with 5,000 or 50,000 users. So the goal is to achieve that scalability. Linear scalability is a term that is used more for deployment. So if your application architecture is such that you can add more servers and get an incremental increase in transaction capacity. By the way, when I'm using the word scalability, I mean transaction scalability. I don't mean data size scalability. That's a separate problem that is not part of the scope today.
What about reporting in queries?
Anything where transaction scalability means that you're just doing a lot of activity. Data scalability would mean that you have a lot of data, like terabytes of data. That's not the problem that we're talking about. We're talking about the transaction scalability. If your application is non-linearly scalable, that means you have some bottlenecks where you'll be stuck. You cannot buy your way out of this. You cannot buy more servers to increase capacity, and after a certain load, the application performance is going to drop until it probably just crashes. You definitely don't want to have that. These are the applications that usually need scalability. Just as a reference, these are the web apps, the ASP.NET, the ASP.NET Core now also, web services, which are also the backend, usually for the Internet of Things devices that talk to a backend. That's a very up-and-coming space. Big data processing is a very big space. Although in .NET it's not very big. Most people who do big data processing do it on the Java side because Hadoop has become such a popular framework. But still, that is the nature. If you have a big data processing application, that also needs scalability in terms of transaction. That also is data scalability, but also transaction scalability.
What about the nonlinear scalability? What about the number of servers increase non-linearly?
Yeah, so if you're in this picture, if your application is in a non-linear scalable state, then by adding more servers, you're not helping anything. So if you had, let's say, a 3-server or 4-server deployment, if you want to go from 4 to 8, you're not going to have any better situation because there are some bottlenecks somewhere that's preventing the application. So you need to address that as part of the application architecture.
So you cannot increase the server non-linearly from 3 to 300 servers?
Actually, what's going to happen is as you increase, it's going to give you less and less incremental benefit until it peaks out and then it starts to go down. Because whenever it's a non-linear, that means every time you add a server, it gives you less increase. So pretty soon that becomes 0 increase, and then it becomes actually a decrease. So that's like, in the mathematics terms, that's the logarithmic curve that you don't want to have.
I have an example of this with I used to use .NET Nuke, and every server in the load balance set had to communicate with every other server in the load balance set.
Yeah.
So if you went from 4 servers to 5 servers, that meant every server, the 4 servers used to have to communicate with the other 3. If you add one, then all 5 servers have to communicate with the other 4. Yep. If you add another one, all 6 servers have to communicate with the other 5. And it would get worse as it got bigger.
Yep.
Yeah.
just as an example of what you're talking about.
Yeah, exactly. Very good, very good. And any other server applications that need to process a lot of transactions? Again, financial services industry, banks, a lot of other large corporations, they have millions of customers. These customers may call to change their addresses, or maybe they're transferring funds, and these usually are processed at the end of the day in a batch mode. That's what I'm talking about, these servers. And they have to get it done within a few hours time frame for compliance or for SLA reasons. So as you get more and more customers, if you have bottlenecks, then you cannot achieve those goals just by buying more servers. So again, all of these applications, if you're in any of these situations, then this is the relevant talk for you. So, it's really interesting because I have red and other colors that I can't see, so I'm also confused today. So where is the scalability problem? I think this was red. I think yes. No, this is better than not, be able to see. So what is the scalability problem? It is not in your application tier. So most applications today that I talked about, all these applications, they generally don't have an architectural flaw. I mean, you could, like he just talked about an application that does, but most applications don't. If you have an ASP.NET application, it has a load balanced farm. The load balancer sends the request to web servers. You can add more servers as you have more and more load. It's the database or the data storage that is the bottleneck. And that is if you're using relational databases. The whole reason this problem exists is because of relational databases and mainframe data. So we exist as a company because there's a bottleneck, there's an architectural flaw. By design, relational databases cannot scale. And there's nothing that the database companies can do unless they make them non-relational. So relational databases by design have to do things together, so they cannot be distributed over 5, 10, 15 servers. Maybe you can have a 2-server failover, maybe even load balancer, but that's about it. Mainframe is the same way. It gives you a consolidated view of something. So that's where the bottleneck is. So even if this tier scales, this is where the whole problem starts, and that's what we have to fix, and that's what I'll talk about today. NoSQL databases came into the market for this reason exactly. That one of the reasons is that NoSQL databases don't have scalability problem. I wanted to give you a quick introduction about our company before I go into any further. So we have a product called NCache that is caching, but we also have a NotchDB, which is an open source NoSQL database. It's a JSON document database. So we have this, and we have customers who use NoSQL databases, but NoSQL databases are not always the answer, because for a number of technical and business reasons, people are not able to move away from relational databases. And definitely on the .NET side, what we've seen is on the Java side, there's a culture of trying new things. On the .NET side, maybe it's Microsoft not encouraging people because their flagship is SQL Server that they don't want to have another. And DocumentDB is really not a real product yet. You can't touch it yet. It's hidden behind the clouds somewhere. But for whatever reason, what we've seen on the .NET side is that customers tend to want to use relational databases, and they have problems because of that. So that's why NoSQL databases are not always the answer, because in order to benefit from a NoSQL database, you have to actually move your data in a NoSQL database. So the more data you put in a NoSQL database, the more you'll get the benefit. But if you can't move your data out of a relational database, then you're stuck. So you have to solve this problem with this in the picture. And that's the reason distributed cache has become so popular. Actually, even with a NoSQL database, distributed cache is very, very useful. But I'm going to go more into the relational. So if you have a relational database here and you put a caching tier in between, here's your application tier. So there's usually a load balancer up here, and you can add more and more servers here, and as you do that, this becomes more and more bottleneck. And to fix that problem, you put a caching tier. Minimum of 2 cache servers. These are usually inexpensive servers. These are not high-end database server boxes. These are dual CPU, like a 8-core box with lots of memory, 1 or 2 network cards. And a distributed cache, by definition, creates a cluster of these servers and pools the memory and CPU resources together as one logical capacity. So let's say and then you should have a minimum of 2, of course, for redundancy purposes and for also high availability purposes. So if you have 2 servers here, you should have a 4-to-1 or 5-to-1 ratio between the application tier and this. Let's say that you started with 2. An average configuration that we see by our customers is 16 to 32 gig memory. We don't recommend going more than 64 gig in each cache server, because to get more than 64 gig, you have to make the processor much faster, because there's garbage collection happening, and the more memory you have to collect, the more the garbage collector has to consume. And garbage collector is a pretty big overhead in any managed environment, whether it's .NET or Java. So 16 to 32 gig in each box is a typical configuration. Let's say that you start out with 2 boxes here, and you keep adding more servers here, and you started with, let's say, 4, now you went up to 8 or 9. Suddenly you'll see that even this caching tier is now becoming a bottleneck. So just like a relational database, the caching tier is also becoming a bottleneck. However, the good news is you can just add a 3rd box, and suddenly it's no longer a bottleneck. As soon as you add a 3rd box, and in case of NCache, you can do that at runtime, so you don't have to stop anything. As soon as you see your load maxing out or coming to this danger zone, you add another box. And as soon as you do that, the cache cluster, in case of NCache, automatically adjusts itself. It knows it has more memory, more CPU. It combines it all, and suddenly you're all fine. Until you max out the 3rd one, and then you add a 4th one, and so on and so forth. That's the real benefit of a distributed cache, is that suddenly you don't have a bottleneck anymore. Even though this database by design is a bottleneck, you've reduced the traffic to about 80%. So that's a huge drop, and it allows you to really take the pressure off of the database. And I'm talking about 80% on the application data. I'll come back to that. There are some other use cases where you don't even use the database anymore. So there's stuff that can only stay in the cache, and only the application data goes into the database. Any questions on this so far?
Yeah, question. Database bottleneck. So can we partition the database based on different regions? We could use Azure services, like a database as a service, so we can deploy multiple databases.
But even if you use a SQL database, behind the scenes, it's still SQL Server. It's a managed database where you don't have to manage the database itself. Fundamentally, a relational database has to keep things. Now, you can partition database into multiple databases, but then your application is suddenly now broken up, and you cannot see data across tables, across databases like you'd want to. So, and most people are not willing to re-architect their application so much that they have to now, the application has to know where the database lives. So people want to continue to use relational database as they did in the past, and a cache essentially makes their life easy, because in the persistence layer you just put the caching calls, and suddenly the pressure is taken off.
With the cache, do you use certain tools to do the caching?
I'll actually show you that.
Does the cache get filled passively, meaning that when people make queries, the cache is filled as they make queries, or does it actually go to the database and say, I'm going to do queries to the database and fill the cache actively?
Both models are there. By default, it's the passive, where as you need the data, you put it in the cache. But there's also that you can warm up the cache. You can preload the cache with data. You can also periodically update the cache from a separate process. All these are features that a good cache, which like NCache, provides you, so that you can determine what data should be in the cache to begin with, what data you want to periodically add to the cache, and then, of course, on top of it, whatever is not there, the application puts it in the cache.
You're not referring specifically to database cache, because database itself will do its own cache.
Right. No, this is your application cache. So the databases have an in-memory cache for performance reasons, but that's not a scalability cache, because that's all within one server. It's only making the database run faster. And that's why I was saying scalability is different than performance. A database has improved its performance quite a bit. You have, because they've done very smart job of caching data in memory, but that's all in one server. So, and you cannot really add load to it. As soon as you add load, the database becomes a bottleneck.
Basically, you reduce the call to database.
That's the whole idea. It's essentially don't even go there. Go there only when you really have to.
So for the 100% statistic, in this scenario, you're saying that's 100% of read traffic, or are you?
I'm saying, well, we've seen 80% of the time, all the reads are done through the cache. 20% of the time, you have to go and update and also do some reads from the cache. Because even, as you said, you have to add data to the cache. Maybe there's a miss. You did a cache.get and the data is not there. You get it from the database and put it. So there's that database traffic right there. And so, the whole idea is not to go to the database. Just as much as possible, go to the cache. Cache is much more scalable. And actually, it's even faster. Even though I said it's not about performance, it is also performance. Because an in-memory cache is faster than going to the database. And we have a NoSQL database, and we have comparisons. It's at least 10 times faster. And the same thing goes with any relational database. A cache is about 10 times faster because it's all in memory. And then cache also has other techniques which can make it even faster than that. Okay. So now that we've sort of established this argument that a distributed cache is something that you guys should incorporate in your application, make sure that you benefit from it. The next question that comes is where should you use it and how should you use it? What are the use cases? What do you use it for? Well, number one is application data caching. That's what I was talking about all this time. That's application data caching means caching data that resides in your application database. So you cache it here, so you don't have to go to the database. That same thing. Now, one thing to keep in mind, again, is because of lack of red that usually reminds me, maybe I should stay here. When you do application data caching, the data now exists in at least two places. One is the database and one is the cache. When data exists in two places, what's the biggest concern that people have that could go wrong? Consistency. So the biggest concern that people have in using a cache is my data going to go stale? That eventual consistency that we were talking about. And a distributed cache that does not address that problem forces you to cache only read-only data. In fact, if you ask an average person, what do you use a cache for? It's for read-only data. Everybody's afraid of putting data that changes, especially if it changes frequently. If you are confident that it's not going to change for the next 2 days, you'll probably cache it. But if it's going to change in an unpredictable fashion, or maybe in a predictable way within 5 minutes, within 2 minutes, whatever, people are afraid to cache. So if you're not going to cache the data, and the data that is read-only or the data that does not change very frequently is what I'm calling reference data. Data that changes frequently is what I call transactional data. So if you're not going to cache transactional data, which is about 80% of the data or more, you're not going to take advantage of the cache 80% of the time. So that whole argument becomes very, very weak. So you really need to be able to cache transactional data. And the only way that you can do that is if you have this confidence that the cache can handle this consistency issue. And I'll go into that more. Second use case is ASP.NET applications. And there are 3 different things that you can use, 2 at least, and the third one if you were not using the MVC framework. The first is the session state. All ASP.NET applications, including ASP.NET Core, have sessions. Sessions are stored as blobs. The standard storage option is either nproc, which is within the worker process, and SQL. Both have scalability problems. SQL also has performance problems. The reason is because SQL was not designed for blob storage. It's a relational structured data thing. So blobs are handled in a sort of on the side thing. Anybody who stores sessions in SQL, as soon as they put something like NCache into their picture, they see an immediate boost. As I said, 10 times faster. So this is the biggest reason people move to a distributed cache like NCache, for example. And it's also the easiest because there's no programming needed to do so. I'll actually go into that in a bit. Even though nproc is faster, it has limitations in scalability because you have to use sticky sessions to send the request back to the same web server, and within that web server you cannot have multiple worker processes, so all sorts of other issues. So even nproc is not, as soon as you talk scalability, nproc is out. View state is something that is no longer being used, but most ASP.NET applications are in pre-MVC framework, so they still have it. A view state is, for those of you who don't know, it's an encrypted string that is sent by the browser by the server to the browser, only to come back on a postback. So and it can be hundreds of kilobytes of string. It goes and stays there, and then a postback comes back. Multiply that by millions of requests the application has to handle, and this is a lot of bandwidth that you're consuming, and bandwidth is not free. For those of you who are involved in the hosting part of the application management, bandwidth is pretty costly. And number 2 is, if you're going to send so much payload, it's going to reduce or it's going to slow down the application response time. So if you could just cache the view state on the server end and just send a small key, it's ideal. And again, no programming needed, it just plugs in. Third is the ASP.NET output cache, which is an ASP.NET framework feature where the page output is cached. So the next time if the page is not changing the output, why not just take the output from the cache? Why execute the page again? And even there, you should use the distributed cache in a web farm so that you don't have 10 copies of the same page output. So there's only one. So these are the 3 ASP.NET specific use cases. All 3 require no programming, very, very quick to incorporate, and give you the maximum benefit in the shortest amount of time. So if go ahead.
Would this be a case where you might consider using state server instead of SQL server as your session?
State server has the same problem of scalability because it does not distribute. It's only one server. So either you have multiple state servers, and then you have the same problem of a sticky bit because each state server contains only its own sessions.
Right, but is this technology something that helps with that? I just don't. In my experience, I haven't used state server very often. But I'm thinking about this in scenarios like, okay, should I use this instead of virtualization? Should I use this instead of state server instead of SQL server?
Think of this as a distributed state server. A distributed cache is like a distributed state server, which is out process, it is out proc, and it can scale. It's all in memory, so it's fast, like state server. State server is fast, but it is not scalable because it's only one process. As soon as you put more load on it, it just dies. And plus, state server also has the problem, it does not replicate. Anything that does not replicate in memory means that your session is going to be lost. I was going to talk about that the nature of the problem here was that you have 2 copies of the data. So it's consistency. The nature of the problem here is that the cache is the master store. Cache, so you no longer keep this anywhere else. You're no longer keeping this data in the database. And when an in-memory store is the master store, then what's the problem that could happen? You lose data. As soon as a server goes down, you lose all that data. Just imagine, you're at an airline and you've run a weekend promotion, and these customers on average are going to buy a few $1,000s worth of airline tickets, and they've done all the flight searches and they've done everything. At the end, right before they hit submit, the session is lost because the server went down for whatever reason. And Windows is known for having a few hiccups. So anything that is kept in the cache, where the cache is the only store, you must have replication. If you don't have replication, please don't put it in there, because it'll bite you in the worst possible time. And with state server, it's even more than that. As I said, it's a scalability limitation and also lack of replication. So that's the second main use case. And the third use case is if you have a lot of applications have workflow built into them. It's not like a traditional workflow where you're not really using a workflow product, but they're sort of coordinating data. So one application does something and it produces data or it updates data. Another application consumes it. And usually they do a lot of polling or other ways. Some people use message queues for that type of coordination. A distributed cache actually is a very powerful platform for that. It's not a message queue. It's a simpler form of a message queue, because it's not supposed to be distributed across multiple locations. It does not persist any messages. It's all in the same data center, but it's a very, very scalable message bus. Think of this now as a message bus, where all these applications are clients and they can communicate to each other through this message bus. So runtime data sharing through events is another very, very powerful use case. There's a pub-sub way of doing it, where one application publishes and multiple applications who have subscribed to it get notified. There's also other event notifications. For example, in case of NCache, you can say, I'm interested in this item. If this is ever updated or deleted, please notify me. Or you can use this feature called continuous query, where you can specify SQL statement. Say, select customers where customer.city is New York. Any customer with that criteria, if it's added, updated, or removed from the cache, I want to be notified. And of course, you can make much more sophisticated criteria. So again, different ways for applications to either communicate to each other through events or to be monitoring for certain types of data changes in the cache. So, and that really simplifies your work, especially because you have the cache already in your infrastructure now. So if you have those types of applications, consider using a distributed cache for it.
The previous picture, is that the cache memory and the server on top are in the same machine?
No, each of these is a separate server.
Server.
So this box represents a cluster. So it's a TCP-based cluster. So they know each other. And I'll go into the architectural part in a bit.
It's a different virtual machines.
These could be different VMs, yes.
VMs on top of those server apps
are separate VMs.
In different VMs.
There could be separate VMs. Technically, this could also be in these VMs, but we don't recommend it. It's much better to have a separate caching tier. But technically, you could. You could have the cache on the same VM as the application.
It's not cache, not in the same machine with the app?
There's a subset of it which is, but not the entire. And I'll go into that in a bit. Any questions on this? Okay, let me first now show you what a cache looks like. So go ahead.
In that slide there in the middle, the previous one, the main benefit occurs when you have multiple servers.
Yes, it's all about scalability. So if you only have one server here, you probably don't need a distributed cache, except.
I meant NCache cluster.
Yeah, so
no cluster, it's one server.
Most of our customers have at least two. So they'll have at least 2 cache servers here for redundancy purposes. It's not, as I said, it's not always for scalability, because in case of sessions, we have many customers who could easily, in terms of their load, get away with just 1 server, but they still have 2 because they want to have replication. So that way, if that session is not lost if any 1 server goes down.
But doesn't it add more load when you replicate the data or manage the data?
It depends how the replication is done, and I'll go into that. So in case of NCache, it does asynchronous replication. So it's all done behind the scenes, so the application is not affected by it. And it's pretty fast, but it is eventual consistency. So technically, you could lose some updates, but you don't most of the time. By the time you ask for the session again, it has already replicated.
So for the cache, I understand the replication thing, but so how often would you go back to the database and actually update the data in the database in this kind of scenario? Like once a week, once a week?
That depends on the data. So there are different data elements have different update criteria. I mean, if it's a customer activity, it'll probably get updated every few minutes.
Question along the lines, are you thinking about this in terms of like information in the cache being replicated back to the relational database?
Yeah, that's right.
Is that a use case you envision, like that you would have something update cache and then cache would later?
Yes,
go
yes.
back to the
That's
database too?
called the read-through, write-through model, and I'll come to that. Okay, let me just quickly show you what a cache looks like, and I'll of course use NCache as the example. By the way, NCache is the oldest cache in the space. We've been around since 2005. So I have in Azure, I've got 3 different VMs set up: Demo 1, Demo 2, and Demo Client. Demo 1 and 2 are my cache server VMs, and Demo Client is an application server. So it's the cache client. In your case, you will have more than 1 client, because if you have 2 cache servers, then you'll probably have 2, 3, 4, 5, 6 clients, which are the clients are your application server boxes. So think of this picture. These are the clients. So I have 2 cache servers, and I have only 1 client just for the demo purposes. So I'm logged into Demo Client on Azure. I'm going to go ahead and create a 2-node cache cluster. And I want to show you how easy it is to do so. So I will use this tool called NCache Manager. I have it launched here. I'm going to come here and say, create a new clustered cache. Can you guys see the whole screen, or is part of the screen?
I'm going to try to reconnect the thread and see if it improves.
Okay. Here's what I can do. Let me actually see.
It's a little harder. That screen's not bad, but the other screen is kind of hard.
Okay. So you maybe want to try it again.
So the relational database is deployed onto a virtual machine, which is infrastructure as a service, right? Is IaaS.
All right. Never mind.
Your database deployed in the virtual machine as IaaS.
No, actually, a cache is a separate caching tier. So think of the cache as an in-memory database.
Right, I'm talking about the database.
The database could be on a VM. It could be on a physical box. That depends on different deployments. A lot of people these days deploy it on VMs because it's easier to manage.
Yeah, which IaaS is not a PaaS.
On the cloud, yes. But if it's on-prem, then you will have your own VM. Even on the cloud, there's a SQL database and there's a SQL server option. A lot of customers who have more serious database use go to the with SQL server option because they control the whole environment. But definitely,
License, right, for the database.
yes, yeah. Okay, so where's my? Okay, I'm going to go ahead and create a new clustered cache. All caches are named in case of NCache, so I'm just going to call my cache demo cache. I'll take everything else as a default. Can everybody see this? Okay. I will pick a partition replica cache topology. A cache topology, in case of NCache, is essentially a data storage and replication strategy. And I'll come to the cache topology in a bit. And I'll hit next. I will pick an asynchronous replication as the default option. I will specify my first cache server, which is demo 1. I'll specify my second cache server, which is demo 2. I'll hit next. I'll pick the defaults on the TCP ports on which the cluster is formed. I will specify how much memory I want to allocate for each partition. In this case, it's only 1 gig. In your case, as I said, it's a 16 gig box. So you leave about 2.5 gig for the operating system and other processes, and use the rest for the cache. And when you give this memory to the cache, that means cache will not use more than this memory. When this much memory has been used, cache will consider itself full. Because anything that is in memory, you have to address this fullness part of it. So when the cache is full, it has one of two options. Either it will reject any new data being added to it, or it will evict some of the older data. And eviction is something that you can do. So in case of NCache, you have 3 eviction algorithms. I will just use the least recently used eviction, and I will evict 5% of the cache. So when the cache is full, it'll evict 5%. I will hit finish here. I will go ahead and add a client, which is my application server box, which is the same box here. And I'm going to go ahead and say start the cache. Again, I just want you to know how simple it is to of course, I have installed the cache software. So on demo 1 and demo 2, I've installed the cache server software, and on the demo client, I've installed the client portion of the software, which is just a MSI.
To your point about garbage collection, are there times when you're, from a tuning perspective, you're better off using less memory? Are there times when you end up throttling, is basically the available memory?
It's. I think. I mean, you should use all the memory that you need. I was only making an argument about having too much memory in one box versus more boxes. Okay. So it's better to have more boxes than to have, let's say, 128 gig in each box. Because to have that much more memory, then you have to make that box much more powerful in processing power, which is usually more expensive than just getting another box.
So this cache management software is installed on demo
1, 2, and also the client. So I am actually logged into the demo client box right now. This could also be on a third box. It could be separately. Maybe you're the IT person who's managing this infrastructure, and on your computer you can have the NCache manager running, and from there you could actually monitor or manage all the cache servers and also the clients.
Is that your company product?
Yeah, NCache is an open source cache. So let me actually quickly show you what that is. So NCache is an open source cache right here. It is available on our website for download. There's also an enterprise edition which has more features and comes with support. If you don't have the money, go with open source. Open source just has less features, but it has no limitation in terms of size. So it's a fully scalable, fully usable. We have lots of customers who use open source, and open source is also available on GitHub. So the source code is also there. So we didn't used to be open source, but about 2.5 years ago we made it open source, and since then it's been good. I mean, since Microsoft jumped to the open source bandwagon, so did we. Okay, so let me just quickly. Okay, now I have this cache started. I'm going to open some perfmon counters. I'll also open this monitoring tool called NCache Monitor, which lets you quickly see all the stuff. And I'm going to run this tool called stress test tool. It comes with NCache, and it very quickly lets you sort of run the cache in your environment to see how it performs, so that you don't have to take our word on its performance and scalability. Most of our customers, when they buy NCache, they actually go through a pretty extensive evaluation like this. So for example, I just ran that tool, And as you can see, it's doing about 900 requests or 800 something requests per server. So I can add one more. Oops. And you'll see that the load will increase. So now it's almost 2x. If I keep adding more and more, it'll keep increasing the load until these two servers will be maxed out. And then you just add a third one. So this is kind of simulating your application. So this stress test tool is doing exactly what your application. It does some gets, some updates, some adds, some removes. So it lets you very quickly, without doing any programming, see how NCache is going to perform in your environment. And then you can also monitor all of that in this perfmon tool. Okay, so this is what a cache looks like. So what you would do is actually go ahead and create this cache on the cache servers, and then also install the client portion on your application server boxes, and just do this whole thing. Once you've done this, now you have a cache, and now you need to start using it in your application. So the first thing that you should think about is ASP.NET specific caching, which is what I've said is the easiest one to incorporate. No programming, just make a little bit of change, and you're up and running. So for example, I've got an ASP.NET application here. As you can see, it's an ASP.NET application here. I'm going to open the web.config. Can you guys see this? Can you all see it? Okay. So I will go ahead, and so what you need to do is add one line here where you need to add the assembly. In case of NCache, this is the session store provider assembly. This assembly is the one that is implemented the ASP.NET framework interface for session storage. So ASP.NET framework has this interface which allows third-party storage to be implemented for session, and then just get plugged in to your application. So for example, once you've loaded this, then you go ahead and make this changes in the session state tag. So for example, the first change you want to make is make sure the mode is custom, because that's what third party means. And second, of course, the timeout should be whatever you think it needs to be. And then, of course, this line is specific to NCache. This line is specific to NCache. And then the only thing that you need to do is specify the cache name. Right here. So if you had gone and installed NCache on those two VMs for the server and then on the application servers, and you had just gone through that NCache manager, that whole exercise is like 10-15 minutes job. Once you have NCache installed and cache configured and the clients registered, you just come here, modify the web.config on all the application server boxes, and suddenly when you run the application again, you'll see that the sessions are now being stored in NCache. And in case of NCache, every session is stored as one item. So that perfmon counter that we were looking at, this cache count, so each one session is one item. So you'll see how many sessions you have. Most people have a separate cache created for sessions than for application data, and I'll come to that also. But I just wanted to show you how simple it is to incorporate a distributed cache like NCache in your application. The only thing that you have to do for the sessions is do some sanity testing. And the reason you need to do that is because if you were using in-proc session storage, you might have objects that are not serializable. As soon as you plug in NCache, your application will break, because you'll see that NCache needs to serialize those objects to put them in the cache, and then you need to go ahead and put the serializable tag on them.
Changing in-process application to NCache, you just need that web.config change. You don't have to change anything in the, like how you store in the session.
Actually, no changes to the application code. The only change is if you're in in-proc storage, you might have some objects that you're putting in the session which are not serializable.
Yeah, you make them serializable.
So once you do that, so that's a recompile of the code.
Right.
But if you are already storing session in SQL Server, then they're already serializable.
Right.
So then the only change that you have to make is this web.config.
Oh, so you are storing as session, but you are actually storing in the distributed cache.
Exactly. Very, very straightforward, very easy to do. And you can do this with the open source NCache also, by the way.
So what about web farm scenario? I mean, like with that.
So think about this. You have a 2-node cache. So we just made a 2-node cache cluster here. I showed you one client, but let's say you have 1, 2, 3, 4, 5, 6, 7 clients here. So you will go and modify web.config on all 7 of them. It'll be the same change everywhere. You have to first install the client portion of NCache on all these boxes. You have to install the server portion of NCache here, create the cache, register these at the cache client, and go and modify the web.config, and you're done.
So that's like the web farm at the top.
Right there. That is the web farm right there. So that is your application server farm, whether that is load balanced or that is some other way. Your application is running. In case of ASP.NET, of course, there's a load balancer here.
Right.
And also in case of web services, there's a load balancer here. But in case of other server apps, there may or may not be. Depends what the server apps are. I mean, but even if there isn't, the apps are running on multiple servers. And the sessions only apply to ASP.NET application anyway. So there we always have a load balanced web farm.
You mentioned about eviction algorithm, right? Is there a way to alert us, okay, when the load is like 95% or like 98%, like send an email or something like that, like a trap?
Yeah, so NCache has a lot of these features. As I said, NCache has been in the market since 2005. So almost anything that you can think of, NCache has. So for example, here you could come here and specify alerts, and one of the alerts is based on cache size. So with the cache size alert, if it reaches, I think, 80% of your capacity, it will send you a Windows event log, and it can also send you an email. And that way you can take the corrective action. There are also other alerts. It's the cache size also. You could also monitor the CPU consumption. You could also monitor the overall memory consumption. And if any of those are starting to go up, then you need to also add more boxes.
Are you going to, I mean, do we have a way to, refresh the cache, the event notification or triggers?
Yeah. So, okay, let me come to this. So far, we've talked only about the sessions. Okay, in case of sessions, there's no refreshing of the cache. Your application is the one that's creating it. It's always updating it. So, as long as the sessions are replicated more than one place, and the cache is scalable, that's all you need. The same thing goes with the view state and the output cache. Now, let's come to the application data caching, which is bulk of my talk. So application data caching, as soon as you come to the application data caching, the nature of the problem completely changes, right? So the biggest concern, so before we even go, with application data caching, you have to do an API calls into your application. In case of NCache, this looks very much like the ASP.NET Cache object. Now the .NET Framework 4.7 also has an iCache provider interface where they will allow third-party caches like NCache to plug in. So if you program to that API, then any cache can plug in. Although there are pros and cons to sticking with just the standard, and I'll talk about that. But the API looks very simple. There's a cache.get, there's a key, which is a string, you get back your object. And there's an index operator which you can do with get and also with put. So there's an add, insert means add or update. If the item already exists, update, otherwise add it. And there's also the remove. And all three have an async version in case of NCache. And the async version means I don't want to wait for the cache to be updated. I trust this, because unlike a database where there are check constraints, there are also other referential integrity constraints which can reject your data. The cache never rejects your data. The only time a cache rejects is when there's some system issues, like there's not enough memory or whatever. So you're pretty safe doing the async thing. But if the data is sensitive where you want to make sure that it is updated before you move on, then you don't do the async, then you do the sync operation. So this is what a cache looks like, and I'll actually show you the application also. So now let's go into your. I'm going to go into. I've got this small console application called basic operations. So to use a product like NCache, what do you have to do? You have to reference two of NCache's assemblies. So there's the NCache.runtime and NCache.web. Then you have to specify two of the namespaces, NCache.runtime and NCache.web.caching. Actually, NCache.web.caching is the main API that you'll be talking to. And of course, if it's an ASP.NET application, the same rules apply if you're going to make the API calls. Not for the sessions. For the sessions, we saw that you only have to load the assembly in the web.config. But for the object caching or application data caching, you just have to. So you do a cache.initialize cache. You specify your cache name, which in this case is whatever we did, and it gives you a cache handle. Now you go and create your objects, whatever way you create them, you do that, and then you do a cache.add. In the cache.add, you do a key, and you do the value.
Where do you specify the connection to the cache?
Right there. That's it. Just the cache name. We use the NCache manager. When we add a client, it actually goes and updates some config files on that client. Let me show you that. Good question, actually. So, for example, I have added this box as the client. It's this box. So I'm going to go here, and I will go into the C program files, NCache, config, and there's a client config. Okay. So when I did this, when I basically added this here, it actually came and made an entry into this file right here. So based on this cache name, it knows of at least two servers. And again, this is something that is only initial list. It's not a complete list, because a product like NCache is highly dynamic. You can add servers at runtime. So those are then registered to the client at runtime. So this is just a starting point to start somewhere. And this client only connects to one of them. So it'll try the first one. If it succeeds, then it'll ask the first one. It'll say, give me. Let's say I'm going to skip a few slides just to talk about this point. So let's say that this client connects to the first server. Okay, and once it connects to it, it'll say, please give me your cluster membership list. At this time, there are only two servers, right? So that server is going to give it names of both the servers. It's going to also get some other information. It's going to say, what topology do you have? It'll say, okay, I have partition replica. Okay, then give me your distribution map. Because a partition replica topology means that the entire cache is broken up into buckets. And some buckets exist on server 1. So this is basically server 1, and this is server 2. So some buckets exist here, some buckets exist over there. So, and usually in case of NCache, there are 1,000 buckets in a cache. So if there's a 2-node cluster only, then 500 each. But which buckets are where is determined at runtime by NCache, and that information is called distribution map that is propagated to the clients, all at runtime. So this is happening when you actually do this call right here. When you do that call, by the time you get back a cache handle, you've gotten all of that done. So for example, you have gotten the cluster membership, you have gotten the distribution map, which is the bucket map. Why do you need the bucket map? Because you want to know where to go. If you want item number 1, you want to come here. If you want item number 3, you want to come here. Because, think about this. If you have more than one server, some data is here, some is here. If you don't know where the data is, then you'll go into more than one hop, right? You'll go ahead and ask the first server, do you have the data? They'll say, no, I don't. Then you check the next one, then you check the next one. So somebody has to know where the data is. So based on the key, it's a key value map, actually. It's a range map. So it says like from A to F is in here, G to whatever is in here. So the distribution map does not really change just by you're adding more data. The only time it changes is when you add more servers or you drop servers. Because, or when there's another feature in NCache called data balancing, where if one of the partition gets too much data, because the data is determined based on keys. So if your keys happen to be in such that they all go to certain buckets, and let's say 500 buckets here, 500. So the number of buckets are equal, but these are, half of them are all full, and these are all empty. It could be based on the keys, that's how it could be. So NCache will automatically adjust, move the buckets around. So the actual data is balanced.
So data will be replicated across servers, right? So then why does it care like where the data is? Like all the nodes will have all the values.
No. Every node, so if every node had all the values, that is also a topology called replicated cache. That is not a very scalable topology because your storage does not increase by adding more servers. What you want actually is like the RAID disks are structured, where as you add...
If one goes down, like we might not get the
We
data.
may lose the data then.
No, because if this server goes down, partition 1 is backed up here. So let me actually, so let's go to this picture. This is a much better picture. Let's say that you have a 3-server cluster. So partition 1 is backed up here, partition 2 is backed up here, partition 2 is backed up here, and partition 3 is backed up here. So every partition is backed up only in one location. That way you don't have to have more than one copy, because having more than more than 2 copies. Having more than 2 copies is actually a lot of extra processing that you may not need, because you don't gain anything by having more than 2 copies. But in this case, so the first part is the partitioning part. Partitioning, even if you don't even replicate, let's say in this case there is no replication at all. This is just the partition cache, which is also something that NCache gives you. Partition replica is the same as partition, but with replication. So partitioning is the first thing, where without partitioning there is no scalability. Because if your buckets cannot be broken up into 1/nth each, then there's no scalability. And as soon as you do partitioning, there has to be a distribution map somewhere. So the clients in this case get that. So every client keeps a copy of the distribution map in case of NCache.
When will you use partition cache only?
Sometimes our customers, for application data, where the data also exists in the database, so you can afford to lose a partition and you just reload it from the database. But what we found out is that most customers prefer not to do that. Because the cost of memory is so cheap, they would rather just add more memory capacity to do the replication. But technically speaking, you could have a situation where you're doing application data caching and you don't want to, you don't have to replicate. Because if you lose a partition, so what? You just reload it. Of course, reloading means that there's a performance hit. Because now all that data that you had, you have to go and get it from the database next time. You know.
So out of 3 nodes, if 2 goes down, there is a chance for losing the data.
If 2 go down within a very short time. So let's say if these were the 3 nodes, partition 3 goes down. As soon as that happens, NCache cluster goes into what we call a self-healing mode. So it immediately readjusts itself to a 2-node cluster situation. What does that mean? That means that when this partition went down, replica 3 became active. Now replica 3 realizes that there are only 2 servers, and it really doesn't belong. So it needs to merge itself with partition 1 and 2. So it will go away, and then once it goes away, then a replica 2 is created in its place. So while all of that is happening, it's a self-healing activity. So we call it state transfer happening during self-healing. In that time, if another server goes down, then you lose data. But the theory of high availability is that 2 failures happening simultaneously is astronomically low. Of course, if you structure your hardware in a way where there's the same one power supply for all 3 boxes, then that theory goes down the drain. But assuming that you've done everything right and each box is really independent. For example, if these are 3 VMs, but they're all in the same hardware box,
So then what monitors that like if a node goes down, like it should go replicate the data?
NCache does it automatically. NCache, so that's what I said. NCache has so as part of NCache architecture is, what I was going to say is a good distributed cache has to provide this. NCache, for example, has this high availability, is very, very important for NCache because you don't want your database to go down, right? So this is also a database. We've just talked about situations where you're putting data only in the cache. So in those cases, if the cache goes down, you're hosed anyway. But even in case of application data, if the cache goes down, you're affected quite severely because suddenly all those bottlenecks will come up. So you don't want the cache to go down. So all of that will happen automatically. So just that one call results in a lot of activity underneath. So each client gets the cluster membership, it gets the distribution map, and it opens connection with all the cache servers. So if it's a 3-node cluster, it'll open connection with all 3 of them. And that's how it can go directly where the data is. So when you do cache.get on item number 3, it knows that that's in partition 2. So that's how it becomes really, really fast.
When we talk about any cloud-only models for distributed caching, or is this all discussions about on-premise type models?
Actually, I'm showing you NCache in the cloud. I mean, what you see the cache here. This is if you see, these are all Azure VMs. So the demo client could be a VM, or it could be an ASP.NET website. It could be microservices.
I guess one concern that I've got, when you use a distributed caching with Azure, like if you were using ExpressRoute, there will be charges when you move caching data across. And I was hoping I could get strategies on how to manage those costs when you're syncing caching across, an enterprise.
So one thing that cache does, it lets you avoid traffic that is costly because you keep the cache as close to the application as possible. So these 2 cache VMs will be in the same virtual network most of the time as your application. So it's all within that environment because, again, you want also fast performance. So why have extra hops? So even if you have, we've got there's one customer that I was talking to, they have microservices in Azure, but they want to keep their database on-prem because they don't have the trust factor yet. So what they want is, so they'll have the cache with the application in Azure. In that case, the client is what we call a thin client. So NCache also has a server only licensing model where you don't have to install the client software. You can just deploy it as part of the application because microservices run in containers. So they will bundle all the NCache client libraries with the application and they'll ship it to the microservices containers. But the cache itself, these 2 VMs are in the same virtual network as the application. So the cache is close to them, and this cache, but the database is far because the database is on-prem. So so they have a VPN between Azure and their on-prem.
So, but the client is a VPN, separate VM also on Azure. But what about ASP.NET application? Just not as a VM, but in Azure.
I think so. Basically, what I'm trying to say here is that you could have. Right. Oops, sorry. So this is your application container. This could be your ASP.NET website, and you don't know how many VMs there are because you don't control the VMs. That's what happens also with microservices, that you don't control the VMs. It could be a web role. It could be a worker role. So in case of Azure, this is some environment, some container where the application is running, or it could be an actual VM. So it depends. I just use the actual VM because it's easier for me to demonstrate. The only thing that we strongly recommend is that the cache itself needs to be in a separate VM in the cloud. So the caching tier, you should have 2 or more VMs in the caching tier.
That is server.
All this server part.
But what about the client part? If we don't need to install?
Yeah, so in case of a container, you can just ship the library with the application.
Oh, okay. So distribute with,
Yeah.
deploy with the...
Exactly. Yeah. So that way, the libraries are part of your application. They know how to connect to the cache because that's how you've configured it. And as I've shown you, there's nothing hard coded. It's very dynamic. You just need to know of one server's name, which you will know.
Your site has to be known to the server.
The server has to be known to the site, the other way around. So the site, the application, when it does the cache connection call here.
When it initializes the cache.
Yeah. So let's say it's going to specify a cache name here, right? So this cache name may be in that config, in that folder structure. It could be hard coded. You can specify the. Actually, let me just quickly show you here.
Because you said that config file is installed on a client.
It's actually interfacing with the cluster, not a specific server.
So, for example, I can have more than one. So I've got this init params option where I can actually specify all of the information through the structure. I don't even need to go to the config.
Okay.
Or I could have the config as part of the application files. So it could be in the same folder as the application. Because containers usually don't like to read outside the containers. So
What
when
about the web.config? Can we put it directly in the web.config itself?
you could, yeah, I mean, that's your application code. So when you put it in most of our customers, the cache name, for example, is they don't hard code the cache name. They read the cache name from web.config. So that way they can change it from dev to QA to staging to production. Yeah. So because it's just a simpler code, I didn't want to put too many other things. But this call, if you can see here, right here, the init params gives you all the structure information where you can specify the server name, everything. And that's the starting point. As soon as you connect to any one server, then everything is done all at runtime in case of NCache. So, for example, as soon as you connect to any of these servers, it will then give you, as I mentioned, the cluster membership, the distribution map, all the stuff is done all at runtime.
How is it persisted? You added it into the cache. How is that persisted into the database?
So, okay, let me come to that. Okay. Good, I think very good questions. I'm very pleased. We're having some really good, meaningful discussions. Okay, so let me quickly now go through a few things, and I'll come to that pretty soon. So let's now start to use the cache. So I've shown you how a cache is connected. You do the simple operations. How do you keep the cache fresh? Well, there are more than one way to do that. Number one is called expirations. Expirations is something that you just say to the cache. For example, here, I'm saying to the cache, I'm saying, where does that go? Where'd that go? Oops, let me first delete that. Okay. So I'm saying I'm doing cache.add. I've got the key, the value, and then I have a date time thing which says expire this 1 minute from now. So by saying expirations, what you're doing in case of absolute expiration here, what you're doing is you're making an educated guess, and you're saying, I think it's safe to keep this in the cache for the next 1 minute, or 5 minutes, or whatever, or 1 hour. And after that, I think it's not safe because it might change in the database. Sliding expiration is a totally different purpose. It's not to keep the cache fresh. It's to do a cleanup. So in case of sessions, or when any data that is transient data, where you want to clean up the cache, where it's no longer needed, so you just want to clean it up. You want to tell the cache, if nobody touches this thing for 20 minutes, please remove it from the cache. That's what we do for sessions. So sliding expiration does not serve this purpose at all. It's the absolute expiration. So almost every cache has this feature, absolute expiration. but the weakness in this is that you're making an educated guess. What if the database is updated before that time? The cache will not know, and you will have the staleness issue. So to handle that, NCache, for example, has this feature called synchronize the cache with the database, where you can use this is an ADO.NET feature called SQL cache dependency, which is also there's called an Oracle dependency, which uses database events. So NCache actually becomes a client of your database. So for example here, let me show you the code example here. So again, it's the same type of a console application. I'm going to go ahead and by the way, here I'm getting, so I'm saying here, just go ahead and go to the definition. So I'm going to go ahead and do a cache.add here. I've got a key, and now instead of having an object, I have a structure. So it's a cache item structure, and within that structure, I add this thing called SQL cache dependency, which is an NCache class that underneath maps to the ADO.NET thing. Because again, you're making this call on the client box. So your call is being run here on this here, but the database connection is being made by this one of these servers. So all of that is being done by NCache. So here I'm saying that I'm really caching a product object. So I want to map that to one specific row in the product table. So I've got a SQL statement with this product ID. So NCache will use this on the server end to create a SQL cache dependency with SQL Server. And now NCache is a database client, just like your application. But now NCache has asked the database, please notify me if this row changes. And if that row changes, NCache will do what? It'll immediately remove that item from the cache, right? Because removing it means what? The next time you want it, you will not find it. And when you don't find it, what do? You refresh. You get it from the database again. So this is a very powerful feature that you must consider using if you cannot predict when the data is changing. And for those databases that don't support notifications, then NCache has a polling-based feature implemented where NCache can poll the database. There's another way where you can actually have a CLR stored procedure make NCache calls. So and that CLR procedure is called by a trigger. So you can go and update the cache directly. Of course, you want to create the same .NET object that your application is creating. So because you're putting that in the cache for the application to use. So it's like the database is also becoming a client of the cache. It's like a circular dependency. So all these different ways are there to make sure that your database is always, the cache is synchronized with the database. And the goal is, if you can achieve that, then you'll cache everything and get the real benefit. And of course, if your data source is non-relational, like it could be a cloud storage or anything, then you can have a custom dependency, which is your code that gets registered with the cache, and cache calls your code. You go and check the data source and see if the data has changed. If it has, then you synchronize the cache. So make sure that you have expressions, database synchronization, and synchronization with non-relational sources to ensure that your data, because non-relational you'll probably use with the legacy mainframe. Because with the legacy mainframe, you usually don't have an ADO.NET type of an API. You have some API, some web methods, or some other APIs that you make calls to. And that's how you configure. Any questions on this before I move to your question?
About the database connectivity, where do we configure on the server the data? The cache server, how do we configure the database connection information?
So on the cache server, actually what you do, so when in your application, you pass a connection string here.
That is to refresh.
No, that is, you're telling the cache server, use this connection string to connect to my database. So this connection string, in our case, we read this from your web.config, right here. So your application is telling NCache, please use this connection string to connect to my database. Now NCache will use that. Of course, NCache has to be able to connect to your database. It has to have all the permissions and all the other stuff. NCache will use that to connect to the database. The database has to be configured to be able to do this, because in case of SQL Server, you have to do a service broker configuration so that it can actually do the events. And there are some details that you can come to our website. I'll quickly show you that. Hold on. There's a lot of information on our website that you can do. For example, if I were to go to the database synchronization part, there's some examples here. There's the CLR procedure. There's also some articles on how to actually configure. So there's stuff on our website that'll show you how to configure the database to do the events.
Is there any way to force a big the data? Like instead of waiting for the database to synchronize, you evict the data from your cache, so it's not there and you bring those.
Yeah, I mean, if you know what that data is, yes, you can. The problem is you don't know, because you're not the ones that has updated the database. This is
I don't know, in case I have an application that has to save that data, insert into the cache, straight to the database, but can I tell your cache, evict me this data from the cache so it loads again?
Yeah, actually, so okay. So what happens in most cases is that you have two ways to update the cache and the database. One is called the read-through, write-through model, which I'm going to just talk about after this. Other is what we call where you directly talk to the database. You go and read data from the database and you put it in the cache. Next time you want it, you check the cache first. If it doesn't have it, you go to the database, you get it, and you put it in the cache.
But you never pull it straight into the database.
And no. So you always update the data directly in the database, and then you also update the cache. So when you're reading, you read the cache. If the cache doesn't have it, you go to the database, and then you put it in the cache. In case of update, you update the database first. Once the database update succeeds, you update the cache. So if your application can do that, then you've made sure that the cache is also consistent with the database. If the data is something that others are also going to touch, other applications that you don't have any control over, that's where you need the database synchronization. Because your application doesn't know. Maybe there's a third-party application or script that is done. So by keeping the cache fresh, you achieve the first major goal of that now you can put all sorts of data in it. The next thing is that if there's a feature called read-through and write-through. Read-through is essentially an interface that you implement. Let me show you. And you register that code. So here. So in case of this, read-through is an interface. Let's say here's the interface right here. So here's your interface. I read through provider. You have an init method, which the init is called when the cache is being started, so that your read through handler can connect to your data sources. Dispose is called when the cache is being started, and most of the time it's the load that is called. So you're passed a key, and based on that key, you're supposed to figure out how to go and get the corresponding data from your database. And then when you get it from the database, then you pass it back along with any other metadata like expirations, resync options, and you pass it back to the cache as an output parameter. The cache, NCache, puts it in the cache and gives it to the application. So think about it. When the application did cache.get, the cache did not have the data. So what it cached to, it called the read-through handler. The read-through handler, so again, everything that we do, I need to put this picture in. So the application did a cache.get here. It went to one of the servers. In case of partition replica, it goes to the server that's supposed to have that data. That server says, I don't have the data. So it can do one or two things. It can either return null by saying it's a miss. But if you have a read-through, you can tell it and say, if you don't have it, please get it. So then the NCache calls your read-through handler, which is registered right here in the cluster. This read-through handler knows how to go to your data source, whatever that data source is. It could be a relational database, it could be legacy, it could be NoSQL, anything. So that read-through handler returns the data to the NCache. NCache puts it in the cache and returns it to the application. So the net effect is that the application always thinks the cache always has the data. So that's one benefit. The benefit of read-through is that you are consolidating your persistence code into the cache. So if you have multiple applications here, they become simpler. They don't have to do ADO.NET anymore. They just do a cache.get, and the cache gets it. And then you have a central place that you're managing all that persistence code. That's...
You don't have to worry about checking in the cache. So you don't have to go through a two-step process of checking in.
Yeah, exactly. So you do just do a cache.get, cache will get it for you. The other benefit of read-through, so the first benefit was that you can consolidate. The second benefit is the auto reload, where you can actually tell NCache that when certain thing expires, or when the database synchronization happens, and you think that data has changed, instead of removing it from the database, or from the cache, why not just reload? Because what's going to happen when you remove it from the cache? The application is going to go back and reload it anyway, which is okay in many cases. But if you have a really high traffic application, we had customers that complained that as soon as they expired an item, they had thousands of requests for that item. They all hit the database, and they all got the same data, all of them added to the cache. So now they had thousands of database reads, thousands of cache updates. So first they did a cache.get, which failed. So there was thousands of cache.get because this thing had expired, right? So then they did thousands of database gets. Now they did thousands of cache updates. So all of them didn't know that the next one has gotten it because the activity is so high. Yeah, but again, it's for really high traffic, and since they had hundreds of thousands of items, or at least tens of thousands, that different items kept expiring, so they were hitting the database all the time. And what they wanted was all they wanted was just refresh these items. So a reload feature really immediately removed or reduced all that traffic, because the item never left the cache. It just got updated. Whenever expiration happened, right here, instead of removing, just get a new copy. And until that new copy comes, the old copy is in the cache. So at some point in time, the new copy comes, but it's always in the cache. The same thing goes with the database synchronization. So that reload in many high traffic applications, even though you put all this infrastructure, you will still have issues if you have that. So that's the other benefit. Write through works just like read through, except it does the writing. Let me show you that. So you have the write through here.
So the read through, somewhere like you are linking the cache key to a method that retrieves the data from database or from any source.
Yeah. So for example, here's your read through. Let's say here's your read through. So when you do cache.get, this key is passed to the read through handler, and the read through handler is supposed to make sense of that key. So your key format will be in a way that it will know what to do, where to go.
Basically, it will be building a dictionary for the key to a handler.
Exactly. So the read through will know how to map the key to whatever database call it needs to make. So the key usually has, if you see the keys for individual items, the keys usually have the class name right here, and then maybe the attribute name, and then the ID. And so there are different key formats that I don't have time to go into, but the key itself needs to be quite meaningful so that you can get all sorts of even queries done. Okay. So in case of write through, it's the same as read through, except now you do the write. And the write, of course, can either be add, update, or delete. So the write through has, again, allows you to consolidate all the updates, but it has another benefit that of write behind. And the write behind's benefit is that you can update the cache in a synchronous mode and let the cache update the database asynchronously. So again, because database is the bottleneck, but it's also a performance issue. So if you could just update the cache for some data, you can afford to do that. If you could just update the cache and go with that eventual consistency model, and it's pretty instantaneous. It's, we're talking milliseconds. And you let the cache go and update the database. Suddenly, your application's updates are also super fast. because you're no longer waiting for the database to be updated. So read through, write through are also very, very important features that you should consider.
Take care of transactional updates on the right behind.
So the write behind itself, if it's going to update multiple tables, it has to do the transaction within itself. But if multiple writes are happening as part of a transaction, multiple write-throughs, then don't do it through the write-through. Do it straight to the database. Commit the transaction. Once it commits, then update the cache. So that's a good question. So if you are doing a database update that requires a multi-table transaction, directly update the database, do commit. When the commit succeeds, go and update the cache. Because we did not implement a distributed transaction in the cache because the performance just became an issue. And if the performance becomes slow, then what's the use of having a cache?
Does the write-through have any sort of retry mechanism built in? Say it writes to the cache, and somewhere the database is down. At the point
yes, write behind does, not the write-through. Okay. Write-through is where you're waiting. Okay. So write-through is synchronous. Okay. You are waiting for the cache to update the database, just like the read-through. You're waiting. But write behind is where it's queued up. And in fact, that queue is being replicated to more than one server, so that if that server goes down, the queue is still there. In case of NCache, so the write behind does read tries also. It also tries to do bulk at times. So write behind has built a lot of intelligence for that. And then if something ultimately fails, it can also notify you through an event.
Also, NCache prevent from two threads in writing using the same cache key or anything. Does it have any sort of locking mechanism?
Say that again.
Like two threads trying to add it to a cache with the same key. So, is there any locking mechanism built in?
Yeah. NCache itself handles concurrency quite a bit, and there's concurrency management at store level. There's also at key level. If you do a cache dot, let's say, if you do a cache dot add fails if the key is already there. If you do cache dot add from two threads, one of them will definitely fail.
So somewhere like it locks, adds it, and then releases the lock.
Basically, what it does, it ensures that only one update goes through on all the servers, and then the second one is applied. It doesn't reject the second one, but it tries to apply it. But in case of add, the logic says if the key already exists, don't add. So then it throws an exception. If you do a cache.insert, they'll both happen.
So the second one will be rejected?
Yeah, in case of add.
In case of add.
Yeah. Because
the application now?
It'll get an exception back saying the key already exists. But if you do cache.insert, then both of them will be updated. I mean, whichever is the one, it'll get updated. Yeah, which it'll override. There's also, in case of NCache, there's also a locking feature where you can actually lock a certain item, and nobody can read or write it until you unlock it or the lock expires. So that.
It's a single threading, and insert is multi-thread.
No, actually, they're both in the same way, but because the way it happens, even when there are multiple threads going, the actual store is locked for the update, for that key. So it's a key level lock at the store. So the same key cannot be added simultaneously by two different clients. Otherwise, it's going to be inconsistent data, right? Because you could have that one copy has got this version and the other copy has got the other version. So that is not. But in case of but if you want to lock something across multiple operations, just do a cache.lock, and then you specify key, and that gets locked. In case of NCache, there's also an optimistic lock where multiple clients can read the same data, but only the first one gets to update it, and all the subsequent updates will fail until they get the new version of the data.
Quick question. All of your examples there have very similar objects. Do you have any examples with related objects, parent-child relationship? You bring one, you bring everything, or table?
Yeah, actually, there's a whole separate talk on how to manage relationships.
Okay.
The reason I didn't put in there, then I won't get done. But you get to pick what the object should look like. So the object could itself be a whole collection.
Okay, so you just put an object which has the cities, the states, the relationship.
Yeah, let's say that you got all the customers based in DC. That is a collection now. That collection could be just one object that you cached.
Okay.
Or you could break it up into 100 different objects with every customer being a separate object. So those are different strategies that you need to handle.
So the cache doesn't handle by me. So I have like the cache object employees, and I either load all of the objects into the employees, or I get one by ID. And I don't know if I loaded like the first 1,000 and I'm looking for the 1,001.
Actually, let me. So there's a complete talk here, handling relational data. So it's an hour-long talk just on that topic, because there's a lot of complexity that you need to handle. One-to-many, one-to-one, many-to-many. You need to do consistency. So there's a cache dependency feature that NCache has, where you can map multiple objects. So let's say if you cache the entire collection as one object, that's okay. But if you broke it up into every object, but you want to be able to fetch it back later on as one collection, then you need to use tagging feature. And then what if any one object is updated? Then the entire collection becomes invalid. What if I delete one customer? Then whatever that collection was, it's smaller than what you cached.
Those are all the questions I have.
Yeah. So I think that's what this talk will address. But good questions. So I'm just going to now start to wrap up. So once you start to do all of this, now you're putting in a lot of data into cache. When you do that, cache starts to look and feel like a database, and then key is no longer a friendly way of accessing data. Then you want to be able to group stuff. You want to be able to use tags, like I just gave the example. What if I want to tag things and be able to fetch them? You want to be able to do like attributes-based searches. So you want to be able to say select customers where customer.city is DC, and get all the things back. So let's say you've cached all your lookup data, and the application logic is that you filter stuff based on the user input. How are you going to do that from the cache? You can't if it's a key-based. So a cache has to. So NCache, for example, provides you with SQL or link-based searching. So it lets you search attributes. It lets you search group, subgroup, tags, name tags. So different ways of sort of categorizing the cache. So being able to find data intelligently is a very important feature that you want to. I'm not going to go into this detail. I want to cover something else. And we've talked about these events. I want to talk about this. There's a feature called client cache. On the Java side, people call it near cache. This is also something that only NCache has on the .NET side. On the Java side, you have other people also have it. So one of the things that many of our customers tell us, if they were using an ASP.NET cache object, like say an inproc cache, and they switch to NCache, they call and complain and say, I was thinking NCache will actually improve my performance, but my performance has actually gone down. So NCache must not be a good product. So basically it comes down to, we say, well, a distributed cache is an outproc cache. It's an out-of-process cache. And in case of this, you have a separate caching tier, so you're actually making a network hop, although it's the same subnet, so it's pretty fast. But you cannot match it with an inproc object on your heap. So they say, well, then I don't want a distributed cache. Well, there's a reason why you need a distributed cache, because that inproc cache is very limited in size. And you have multiple copies of it, they got out of sync, all the other issues. So to handle that concern, then we have this feature called client cache. So a client cache is that inproc cache. It keeps things in an object form on your object heap, but it's smart. It knows it is part of a distributed cache. It stays connected to the caching tier. So whatever object is kept in the client cache, it keeps a link with the distributed cache. So if that same object is updated by another client, the distributed cache notifies the client cache. So the client cache can update itself. It's done asynchronously, so it's eventual consistency model, but it's fairly fast. As I said, it's in the milliseconds. And most data that you put in it, it's perfectly okay. And in case of NCache, there's also a model where you can go with this, what they call pessimistic synchronization, where you always assume that the client cache has got old data. So, and then you always check to make sure it doesn't have the old data. For some of the data, you can do that. The client cache in case of NCache is something that just plugs in. So there's no extra API calls that you make. You just make the same API calls that we just talked about. Plug in the client cache. It becomes another read-through, basically, that we just talked about, except it's the read-through within the application. That whatever that cache.get that you made call, it goes to the client cache. If the client cache doesn't have it, the client cache calls the caching tier.
It's a different object in the API?
No, it's the same. It's the same object. Your application doesn't even know there's a client cache. It's a configuration change. So you just plug it in through configuration. This is a really powerful feature that we recommend almost all of our customers to use because it gives them that same performance. Of course, a client cache is a subset. This, as I said, let's say if you have a 3-node cluster, 16 gig each, this will probably be just 1 gig each. And multiple client caches will have the same data based on their usage pattern, but they'll all be synchronized through the caching tier.
I have a question with this diagram. Let's see the box could be a virtual network, and the servers, apps could be a subnet, and the cache cluster could be another subnet.
Actually, in this case, I expect all of this to be the same virtual network. In case of cloud, we recommend to put the cache in the same virtual network. Although it doesn't have to be, you can go to a separate virtual network. They just adds more extra hops for.
It's a once virtual network.
Right.
And inside the virtual network, there's subnet.
You could have So you could have that as a subnet. Yes, you could.
The app server is also subnet.
Yeah.
The same.
Yeah. And actually, if these are your websites, then you don't even know how many VMs are there. Right. So it's all hidden. So, but the client cache will be part of the application. So it's all in proc. If you want an out proc client cache, then you have to install the client portion of NCache because there's a separate server process or that service process that gets installed on the client box. But in case of an ASP.NET website or microservices, we just recommend to customers that they should all use in proc client cache, which is within the application process. So then they don't have to install anything on the client. They just ship the assemblies. But this feature gives you the benefit of the old in-proc cache for performance, but the scalability of a distributed cache. Any questions on this?
Which approach is more popular, this one or the...
Most of our customers who use the client cache use in-proc, but the only time they use out-proc is when they have a lot of worker processes. So let's say some of our customers have 8 worker processes per web server. So instead of having 8 client caches on the same box, they just have 1 out-proc cache. The out-proc cache is still much faster than going to the caching tier. It's not as fast as the in-proc, but still. And not to mention, it also takes the pressure off of the caching tier. So it's like a cache on top of a cache.
You will evaluate your environment before choosing one of these.
So,
how many processes are running, what kind of...
Yeah, so basically, we recommend that if you have any data which is read intensive, you should always use the client cache. So basically, if you come to this right here, in the ASP.NET specific caching, we do not recommend that you use a client cache because this is not a read intensive operation. For every one read, there's also one write. So the number of reads and writes are equal. You do one get of a session, and at the end of the request, you save it back. Let's say you click on a page from the browser. It goes as an HTTP request to the web server. The web server goes and reads the session. The page executes. You put stuff in the session. Before the response comes back, the session is saved back. So the number of reads and writes are equal. In that case, the client cache actually makes matters worse because now the updates are being done in 2 places. The client cache and the caching tier. So we don't recommend that you use the client cache for this or for this also, but definitely for this. For the application data caching, so normally our customers, we recommend they have 3 caches on the same VMs. One is called the session cache, one is called the application data cache, or some call it object cache. Third is called reference cache. So with reference cache, they use the client cache. With the application data cache, they may or may not use the client cache. And with the session cache, they don't ever use the client cache. And by keeping them three separate, they also have a better way to manage. For example, for session cache, they know how many sessions are being created because each session is just one object. Any questions? So we've talked about the dynamic clustering. We talked about the topology. In case of NCache, there's a WAN replication feature. A lot of customers are now going multi-data center, especially with the cloud. It's become very easy because you don't have to invest in your own data center infrastructure. So as soon as you have more than one data center, you expect your database to be able to handle it. So why not the cache? So NCache has features. So there are two ways NCache handles. One is called a bridge topology, where the entire cache is replicated to the two data centers, either in an active-passive or active-active. And the other feature is what it was just a small line here. Multi-site sessions. So in case of NCache, we implemented this as a special session storage mechanism for one of our large airline customers in Europe. They had three different data centers, London, Dublin, and Frankfurt. And they didn't want to replicate sessions because they wanted, their traffic was pretty much regional. But they wanted to be able to overflow. And when a user was bumped from one data center to the other, they wanted the session to move. And that also give them the ability to bring one whole data center down and let the sessions move to the other one. So the multi-site session feature also allows you to handle multiple data centers that way without doing the replication. Of course, NCache has got lots of customers. So I want to do a very quick overview of NCache versus Redis. First of all, I want you to know that there's a very detailed feature level comparison on our website. So if you come to our website, go to the comparisons, there's a Redis versus NCache feature level comparison. So it gives you a whole, and of course you can also download the PDF. So if you can see the PDF here, it's a full-blown like a comparison document and everything mentioned and explained in terms of what it is. But just to give you and also there's another video. And again, the only reason I mention this because these days a lot of .NET folks, they know Redis being Microsoft's choice for Azure. And I want you to know, Microsoft picked them because in Azure, they have to project themselves as a platform-independent environment. So Redis supports a lot of different languages. NCache is .NET-focused cache. We do support Java, but we're a .NET-focused cache. So if you're a .NET-focused application, you'll see that NCache has a lot more to offer than Redis, and I wanted to sort of point you to it. So there's a comparison. There's also, there's also a talk that I gave, 6 reasons. This sounds more like a sales pitch, but it's not actually. It's actually a technical talk that I gave, which goes over all the features that NCache has in 6 different categories that they don't have. So I think I would strongly recommend that if you are considering using a distributed cache and you are considering Redis and NCache both, that do a comparison. But just to give an overview, they're both open source. NCache is also on GitHub or also on our website. They're also on the Azure Marketplace, Amazon also. And the Enterprise Edition, in case of Redis, is by Redis Labs, not by Microsoft. Only on Azure that you have the Microsoft supported. And Amazon or any other platform is all by Redis Labs. And Redis Labs is a Linux-focused company. They don't even support Windows platforms. If you go to their website, they've recently added a Docker download for Windows, but not a native installer for Windows. Whereas NCache is all about Windows. Our products are always certified on the latest Windows because that's our bread and butter. So we do both on-prem and the cloud. In the cloud, we have the VM model, which is different than their model. They have a service model.
It's a microservice?
No. The cache as a service model, where you don't know the cache VMs. You just see the cache as a service that you make API calls to.
It's a microservice implement.
No, microservices are more your applications. They could call either this or this model, but the cache itself, in case of Redis, it's a service. So you don't see the VMs. Similar to the microservices, you don't see the VMs. In case of NCache, we've intentionally chosen the VM model because most of our customers are very serious on caching. They want to control their cache. They want to have all sorts of server-side features that we just talked about. So there's a read-through, write-through, right behind. There's a cache loader that we talked about to like warm up the cache. There's a custom dependency, map reduce, aggregator, entry processors. There's a bunch of features that are server-side features that NCache gives you that you cannot have on a service model because you don't have access to the cache. You just make the API call. So that's one. But on top of it, there's a lot of features. If you go to that 6 reasons why, it'll go over all the features that NCache has. I've covered many of them also, but I didn't cover it in a comparison way because my goal is not to do a comparison here. It's just at the end I wanted to kind of give you an overview. So just do your research. If there's any information that I can provide, please do let me know. I would really appreciate if everybody registers on that sheet that I gave. We're going to do a draw at the end. I'm almost done now. I'm pretty much done. So you can come to our website and download NCache Enterprise, or you can download the open source. You can also get the open source from GitHub, and also the NuGet packages and all the other stuff. Any questions before I complete?
It's in the Azure Marketplace. If we use that, we have to pay for that?
Yeah, so if you come to Azure NCache Marketplace, I think it'll be here. So there's the open source, which you don't pay for NCache, but you pay for the Azure VM. But there's, of course, it's as-is basis. There's a professional edition, which is basically open source with support. But what I would recommend that you do, if you're going to go to Azure with NCache, is to use the NCache Enterprise. Where did that go? There. So you can come to Azure and you can just get a VM. Again, it's a VM-based model, not a infrastructure. So, and you get like the first 60 days of use is free, and then afterwards you have to pay. But not free in terms of the VM. Microsoft doesn't give you anything free here. So it's the NCache portion that is free.
For testing or development purposes, is it okay running the client, the cache, and everything on the same computer?
Yeah. In fact, for dev install on-prem, there's no license needed for the developer workstations. It's only for the server side that you need the licenses.
Okay, no, I'm saying just for installation. I need to evaluate this.
Yeah.
Software. Can install the 2 versions. So I'm going to have database server.
Yeah.
Application server.
Everything can be on the same box. Everything can be on the same box. And so, but I would strongly recommend that you download the Enterprise edition here. Even if you're going to use some other edition eventually, you start with this. It gives you all the features. It's a 60-day fully working copy. And it can easily get extended.
Yeah, I think this NCache scenario is good for you have a database backend on-prem, you have this application service in the cloud, then you use a caching.
That is one. Even if everything is in the cloud, you can still use it. Even if everything is on-prem, you can still use it, because it's the scalability that you will use it for.
Well, I mean, if we develop an entirely new application in the cloud, all the data is in the cloud, there's no need for NCache, right?
There is.
NCache is good enough.
if you use SQL database, it still has the same problem that I talked about.
I mean, we use Azure SQL, which is SQL
Yeah.
as a service.
Yeah, but behind the scenes, it's still a relational database, so it has the same problems.
Same problem.
Yeah.
Is that going to be replicated, multiple database same?
No, it's the same. It's essentially, it's like a SQL server, but in a managed way. That's all.
Is that a .NET Core client library?
We have ASP.NET Core. We're working on .NET Core now in .NET 4.7. They've added serialization and reflection. So we're going to now move to .NET. So we were waiting for them to add features. So as soon as we're able to, we will be releasing on .NET Core. Good question.
So the tool that you showed, right, where you added all the servers and all those things, do we have any other, can we do it from PowerShell or console?
You can, yeah, all that I showed you, you can do it through scripts also. Okay. Everything can be done through scripts. Thank you very much, guys. I appreciate it.
I need to stop the question.
No.